Newcastle and Stafford College, end of year test 2020. Question 11 could be about APs. What do you think? First part, 3 marks. Prove that sum up to n terms of the series is that. That's a standard. Prove that we need to learn and be able to regurgitate. This case we only get 3 marks. Very often it's worth 4. And then we've got another sequence which is given by this. Well, that bit there makes it look unusual. And we got to answer 2 questions. First one looks quite easy for 1 mark. What's the 5th term? Well, that looks as if it's going to be fairly straightforward. And then we've got to interpret the sigma notation. It means find 59 terms and add them all up. And yeah, 59 sums, and each one that we're going to sum is a different part of our sequence, going from the first term right up to the 59th term, and then we're going to add them all up. So that looks a little bit tricky for 3 marks. The first 3 marks though, for part I, is pretty standard. We're going to write the sum of n terms, because that's what we need. The sum to n terms of this series is given by the first term plus the second term, which is an a plus a d, because we're told the first term is a and the common difference is d. Then we've got a third term, which would be a plus 2d. And then we've got lots of other ones that we're going to add up, finishing off with the last term of our sequence, which is going to be a plus n minus 1 lots of d. And we're going to write this again the other way around. We're going to start off with the last term, a plus n minus 1 d's, plus the term that comes before that, which will be a plus n minus 2 d's. Then we're going to add our next one, finishing off with the last couple of terms here. A plus d is our penultimate term when we write them backwards, and then plus our first term when we write it, which is our last term when we write it backwards. And then we're going to add them up as if they were simultaneous equations. And if we add s and sn, sn and another sn, we've got 2 of them, that's equal to our first term plus our last term, which is a plus n minus 1 lots of d. Then we've got this term plus that term, so I've added those 2 terms up. Then next I'm going to add these 2 terms up, which is an a plus a d plus another a plus n minus 2 d's plus dot 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 all the way up to my last couple of terms, which will be a plus n minus 2 lots of d plus an a plus a d, and then finally plus the last term, which is this one and that one, so a plus n minus 1 lots of d plus another a. And we can see when we add all these up that I've got a 2a plus an n minus 1 lots of d in that first one, plus another 2a's. When I add d onto 2 less than n d's, I get an n minus 1 d, plus all the way up to the last couple, but I'm just going to write the last one here. I've got 2a's plus another n minus 1 lots of d. So I've got lots of terms and they're all the same, look. 2a plus n minus 1 lots of d, another 2a plus n minus 1 lots of d, plus lots of others, and then finishing off with the last one. Well, the number of terms I've got here is the same as the number of terms I started with, and that was n terms. So I could write this as n lots of 2a plus n minus 1 lots of d. But that's what 2 SNs are equal to. So 1 SN would be half of the right hand side, plus n minus 1 lots of d. And I can put a therefore at the end because it's a prove that. So I've started off with what I understand my sum to be by thinking about individual terms, n of them. Then I've reversed that and added corresponding terms, so that I end up with lots of terms which are the same as each other. How many have I got? N of them. And then we just divide to get to the bit that we want. So I've got those 3 marks. Part 2. u5 is equal to 5 lots of 5, because the n there is the same as these two, plus 3 lots of minus 1 to the power of 5. Well, that's 25. Take away minus 1 to the 5 is the minus 1 times 3, and that's equal to 22. And part B is slightly harder. And to understand what's going on here, so that we can add 59 terms up, we're always in a good position if we see what the pattern is to our terms. If I write this notation out, sigma notation out again, 59 un, that's equal to my first term, which is sub 1 in there. So 5 plus 3 times minus 1 is 2. Then I had to add my second term, which is 5 2s or 10, minus 1, so n is equal to 2 this time. 5 2s are 10, minus 1 squared would be plus 1 times 3. So I've got 10 plus 3, which is 13. Then my next term is when n is 3. 5 3s are 15, plus minus 1 cubed is minus 3, minus 1, sorry, times 3 is minus 3. So I'd have 15, take away 3, which is 12. My next term, when n is my fourth term, when n is 4, would be 5 4s are 20. And this time, minus 1 4 is a positive 1 times 3, so I've got 20 plus 3 is 23. My fifth term, when n is 5, would be 5 5s are 25. Well, it's 22, we've already got it. Plus, so 1, 2, 3, 4, 5, I'm on my sixth term, 5 6s are 30. Minus 1 to the power of 6 is a positive 1 times 3, so I've got 33. And my next one is when n is 1, 2, 3, 4, 5, 6, 7. So 7 5s are 35, plus minus 1 times 3, which is 35 take away 3, 32. And I think I can see what my pattern is. I'm going to do 2, skip a term and add 10, take away 1, skip a term, add 10, skip a term, add 10, skip a term, add 10, skip a term, add 10. So I've got two sequences, if you like. So I've got 2 plus 12 plus 22 plus all the way up to my 59th term, which is an odd term. 5 times 59, take away 3, would be my U59. And 5 59s are 295. Take away 3 is 292. Plus, starting at 13 now, plus 23, plus 33, plus, and so on, until I get to the term previous to that one. And so we can see that the term previous to this one would be 293 by thinking about the sequence above it. Then we can check that by saying U58 would be equal to 5 times 58, and then add 3 this time because my n is an even number. Minus 1 to an even is plus 1 times 3 is plus 3. 5 58s are 290, add 3 is 293. So this is 29 terms, and this is 30 terms, because I got a first one and a last one which is odd. This one I start even and finish even, and 30 plus 29 is the 59 that I started with. So my sum is actually two sums. So I've got 30 terms divided by 2, double my first term, which is 4, plus n minus 1 lots of d. I'm not going to do that. I've got my first plus my last, and then I'm going to add 29 over 2 times first one, which is 13, and my last one, which is 293. So here I've used Sn is equal to n over 2, first plus last, that version of the sum of an AP. And when I multiply this out, I get, so it's calculator time, but when I multiply this out, I get the sum, which is 8847. There's a different way of doing this, and I think we should learn that way so that we could, if we get something like this again, we could check it a second way. And a second way of doing this would be to say, well, I've got, my first term is 5, take away 3. Then I've got 2 5s, add 3. Then I've got 3 5s, take away 3. and I've got all these plus and minus 3s, and I've got a sequence which is 5, 10, 15, 20, 25 and so on. Take away 3, add 3, take away 3, add 3, take away 3, add 3 and so on. So I've got an odd number of terms. So every pair of terms here adds up to nothing. My last term will be a take away 3, and that's on its own. And apart from that, I've got 59 terms starting at 5 and going up in 5s. So I've got 59 divided by 2. 5 times 2 is 10, plus n minus 1, which is 58, lots of 5. Then if I take away that 3 that I've got left, that works out to 59 divided by 2 times 10 plus, let's put that in bracket, 10 plus 58 5s, and then take away 3, and that's the same 8847. So I'm quite happy with my 8847.